Hi, good afternoon. I'm Michele Bustamante. I'm here to talk to you about surviving microservices. And I might like Game of Thrones. I'm just going to throw that out there. So what I'm going to do is take you through a tour. I do a lot of this day to day with my team, with our customers, designing microservices, deploying them to production, dealing with all of the trouble and complexity. And so I pulled this together as a story of kind of summing up the things that will help you along your journey, if you were to go down this road, from the beginning of the design phase to getting to production, hopefully safely. So that's what I do day to day, and hopefully I can share a few tips with you. So let's start with a message, and that is, well, we're going to talk about microservices, but I'm going to lead with most of you might not need microservices. And the reason that I say that as an intro is that people take the principles of microservices obviously very seriously, and you'll start going down the road of design, and then you'll realize, well, I have to make some choices, and they're tough choices, right? I have really usually I can only pick with this, you know, with the cheap, fast, and good, I can usually only pick two, right, when you think about software development. But the reality with microservices is it's even harder because it has to be good. Because if you don't do it right, you don't do it well, you won't survive it. You literally will not be able to, you know, keep your production up and running. So you need to invest in this process. And therefore, it will not be fast because you got things to learn, new development procedures, new ways, new workflows within the development cycle and the DevOps cycle, new tools. And it's not going to be cheap because that means you have to invest in that with team members, more bodies, maybe some consulting experts, people that help you along your way to get the first MVP launched. And so with all that good news, maybe let's just say that when you're going to go down the road of doing microservices, you need to play to win or you'll fail. So how do we play to win? What do we do to survive this process? Well, first of all, maybe make good choices. So if you're going to make poor, uneducated decisions and just kind of say, hey, it looks like microservice is a good idea. Let's build a bunch of little things and throw them up in the cloud. It'll all work, right? I think so. But, you know, he doesn't make it. Spoiler alert. But if you gather knowledge, take your time, try to make good choices, take the time to do the first MVP right, and you know, do the learning that it takes, well, then you'll probably make it. And by the way, this one has dragons, and I don't know about you, but if I was in production with microservices, I kind of want the ones with the dragons protecting them. So I think we run with that. So the way to survive, the things that I've pulled out here have nothing to do with something that you'll read in a book that will say, here are all the principles, here's the things you have to do. This is a little bit more specific. This is a concrete set of things that I've personally chosen around the things that I see struggles faced the most, which is in the process of why, choosing if you should even do this, in the process of design and development, troubleshooting, things like eventual consistency and messaging, and then integration and launch, because those are the final steps to go live. So I'm just going to kind of go and attack this one by one, but what I'm going to do is focus on this with in mind that you would do all of these things for even an MVP. So, to survive, why? Why do you want to do microservices? Question number one. And there's a lot of really bad reasons too. You know, you'll see all these things. The internet will always prove concepts of, you know, what people are doing out there, and therefore it must be good, right? Like Docker adoption and container platform adoption, and you know, all kinds of momentum behind it. You know, you don't want to be left behind. And those are not good reasons to do it, because the reality is you're not them. You have to make these choices for your business, and it is all about your business. But wait, there's more. There's all kinds of really bad reasons. For example, marketing, right? You think, hey, I'm going to throw the word microservices on our product. You know, that's going to probably sell more. Isn't that a great idea? You know, hashtag containers, hashtag microservices, everything. Not going to work. Monolith to microservices. It must be the only way, right? If we're going to leave the monolith, we have to go all in. And that's just not necessarily true, because you could just do a really bad job at that as well from the previous time. And of course, developers like it. So if they're pushing from the developer side, hey, yes, we got to do this, it's really important, the business still has to help decide, is this really the right fit for us? So probably not, the best way to choose, because it doesn't pay the bills. And containers are fun, whatever. So the thing is, throwing containers and throwing microservices at the problem doesn't necessarily solve the monolithic issue. No more than you throw dragons on a fire, and that will automatically mean that you're going to hatch some dragons, and they're going to be like your children. But what you do want to do when you think about microservices, the first and most important thing you can do is, as a business, with the technology team, with the stakeholders in the business, understand, what is it about moving to microservices that will align better the release of features, for example. What are good reasons to do microservices? Are there things we're struggling with, such as, rapid releases of features? Are we having trouble doing that with confidence? Is there something we can do that will make it a little bit easier, more isolated, and more predictable? Do we want to improve the system's resiliency and in the process adopt these modern tools that help make that work better and maybe at least start heading in that direction as a rule and as a process as a company? Do we need more visibility into operations, even not just instrumentation, but also the business? So whereby something like messaging might be useful because we can have now visibility of activities cross-cutting across different application solutions, even off-the-shelf products, into the whole business operation so that business people can do their job better. Do we want to maybe incorporate a distributed, group of developers to where each developer could use the right tool for the job, not just because they know it better, but also because maybe it's the best tool for the job, but still have the same deployment experience, which means containers. Those are good reasons. Having heterogeneous teams, also useful, right? So I think when we think about being able to have that flexibility, it can add value. Now, all of the tools that come in the microservices, space right now support this, right? We have containers. Containers make that encapsulation easier, that predictability more easier. The platforms help us with deployment and management and self-healing of the operations. Certainly there's tooling around that that's tangential, around operations, instrumentation, visibility, dashboards, and so on. So all these operational practices that kind of go with the mantra of microservices are the things that help you to be successful. And then there are the design principles, which also help inform how we tease apart the monolith. But that being said, again, all of these reasons that might be good to go to microservices, for example, around adding features more quickly, releasing with confidence, still really don't mean anything until you've aligned that with what is your business problem right now. And so when we think about each of these potential reasons why microservices is helpful to me, as a company, we have to take that and map it to valuable things in our business, right? So thinking about, for example, not being able to meet customer demands for features. Okay, so a rapid release cycle with smaller things that don't stomp on other things, that don't get in the way of regression testing or introduce problems. That's a really good reason to consider going into that direction. Releases are filled with risk. Okay, so how do we improve that? Again, the tooling, the ability to do rollbacks more easily and self-heal the solution. So then we get into, well, container platforms do provide some of that, right? So is that going to help us over time if we start moving in this way? People have trouble sometimes tracking down things that go wrong in the whole operation of the business with off-the-shelf products, back-end systems, synchronization of databases. People have workflows, maybe order and fulfillment procedures that hit not just customers from the website, but also back-end fulfillment. And I can give you an example. I've had some customers, literally where developers are the ones being called when something's not in the place it should be, because they need to hunt down, did that file drop happen? Did the thing that processes the file get it into the mainframe? Did the synchronization job happen after that? Where did we land and why isn't it here? That's a good reason to move forward with, a new solution that might include, say, messaging, right? So that we can now start building dynamic workflows around the state of what's going on across all these different solutions. And then, DevOps tools, having more consistency there if you have different types of products that you're deploying across the ecosystem of your applications for customers and back office. Managing those in a consistent way means investing in maybe one type of orchestration platform that you can really just learn to do well and start getting better dashboards and instrumentation and security, and not have to have this polyglot sort of situation where you're trying to cover too much ground. But none of this means anything until you match it to dollar value. Because if the business is not going to see something of a benefit after the first MVP goes live, then all the money you spent to do that is just going to go down the drain. Because they're going to say, this is too expensive. How do we know the next release won't be just as expensive? And I got nothing. So the number one thing you can do to survive why is really take a step back and think about what is it that the business needs in order to survive, right? In order to, I guess, make it worthwhile to spend the money, to adopt these new practices, to spend this time on this first launch, okay? So that's the number one thing. So once we've figured out, yes, there are some business drivers, and maybe we've even identified a POC or an MVP that will make a great first launch, or some idea of a problem that we want to solve, that at least those would be where we're going to identify the first services to go. When we get to that point, now we have to survive design. And design is hard, right? Because, it's always hard, right? Software's hard, it takes time. But it's so important when we start digging into this new ecosystem of microservices, because you want to plan for the future, you want to position yourself to be successful into the future. And so to survive design, I like to take you through maybe a couple of high-level steps that seem to help in terms of teasing out what are the moving parts of the system, and then we're going to marry that to what are the things we really want to solve. So for example, the first thing you're going to do probably is say, what are our main business domains, right? So you want to go to the top level and say, okay, well, we have these different things in our system. We have product catalog and recommendations engine. So maybe we sell things online. There's a shopping cart. There's payments and orders, obviously, so we need different solutions for those things. We have supply chain management, maybe in fulfillment for product shipping and sales, think like an Amazon or something like that. And then we've got, customer relation management, customer support. These are all tools, software, some of them front-facing, some of them back office, some of them part of different divisions of the org. And of course, somewhere in their identity management, people have to log in, people have to call APIs securely. They have to manage their SSO session, integrate with other providers. So there's different features, right, that live in each of these boxes. And the first thing you're going to do is say, okay, well done. I think we found our domains. So each of those boxes is a microservice, right? But that depends. And so now we got to open up the box of maybe one of these domains and say, okay, well, let's take a look at 5, 6 use cases and try to tease out what do users really do in here? And let's take identity as an example because it's something we all know, right? We all log in places. We know what logging in means. We know user management. So the first thing I might see is that there's user single sign-on. And single sign-on is, I log in, I log out, I have a session. Maybe it takes me over to somewhere else to log in, like my Google account or ADFS. But the point is, there's a set of features in here that make sense in identity. And there's a user object, which is probably my aggregate. The next thing I have is user management. Create users, activate, deactivate users. Maybe there's other features of the user. Unlock the user if there's, for some reason, the need to do an immediate unlock instead of a timeout. So these are things that happen with a different UI, different sort of set of users are interacting, but there's still a user domain. It's a user object, it's got an ID and a password probably, and maybe relationship to other logins. And then we have user self-service, self-registration workflows, confirm my email, forgot my password, change my email, confirm the new one, that kind of workflow where I might have a whole set of UI around that kind of feature. Maybe it's even linked to profile in some ways. And then we've got permissions, which is what am I allowed to do in all these apps? So the first three talk about users. I might start thinking, well, that's a microservice then, right? The whole set of user things. But maybe permissions, we can start to see it's a different aggregate. It's a different set of data, right? It's related to users, but it's sort of got its own management story, its own life cycle for features. And then we might have a user profile that in some cases is just a first name and a last name in the user database. And in other cases is a very rich, profile with links to accounts and dashboards and things I'm allowed to do in the ecosystem of this product, for example. So we're looking for, does identity, which we first thought was just one big domain, maybe have a few domains inside that we can isolate based on the premise of, what is the life cycle for change? When I change how we manage permissions, does that affect identity? No. So I can probably safely make that a smaller set of microservices. Same with profile. If I have profile and dashboards and accounts and things like that, then it makes sense that maybe that should be a separate one. So this is the way of thinking. We start big, we drill into some use cases, we learn about the use cases, and then we tease it out. But we need to do that for all those big domains to sort of start really thinking out of the box. Because the last thing you want to do is say, I already know the system, here's the breakdown. That's a very technology-oriented way to determine your domains. The real way is to think about the user and the stakeholder. How are people using these parts of the system? And do they have a separate life cycle for potentially deployment, updates, feature requests, and so on? And this is just identity, and we've already found 3. You can imagine the rest of your system, how even customers and orders might have completely different front ends and life cycles to manage it, even though they all work with a piece of order or customer data. So keep an open mind, go through the process, tease out your aggregates. And with the aggregates, of course, what we're looking for are single transaction updates to that data store so that the microservice can own its data. And so when we look at it this way, the user, for example, is related to permissions and profile. And the rule of DDD is that that would just be related by its identifier. But there's no other crossover. A single transaction update for any particular method call updates the aggregate within. And that would be what's owned by the service. And each service may or may not have multiple aggregates, depending. But an aggregate never appears in more than one service. So it's owned. So once we get through this process, now we're thinking about, okay, look, I'm an architect or a developer. I've been at the company 20 years. I know exactly how it works, in and out, upside down. We need to sit down in a room and start going to the whiteboard and thinking about this microservices breakdown. And the process for doing that is, like maybe in a week you could sit at the whiteboard and get a lot done, get through that 3 to 5 use cases for somewhere up to 10 domains and really start teasing out what does this feel like it's going to head towards in terms of architecture. But then another interesting thing happens. I've done this before where I've gone and talked to people and it's time consuming, right, to sit and talk and ask about these use cases and they kind of just want to be done because they say, well, I already know, like this is how this is going to work. And I said, well, you know what, I don't know the domain, so let me just ask you some questions. Let's gather. And we start to gather, and I say, maybe we can get the business, stakeholders in the room so we can understand how they're using this UI. I already know how they use it. We basically, have been working on this for 20 years, like I said. I know it inside out. And then I'll get to a point where I'll say, well, why couldn't we do this? Or how does this work? And then they'll say, you know what, we need to bring so-and-so in the room. And this is a true story. We sit in the room, and we go through the question again, and this stakeholder comes in and says, well, the only reason we do it that way is because the UI doesn't let us do this. So this is what I really want to do. This is the workflow I want. And so now we've just uncovered, because we included all the right people, actual use cases. So the worst thing you can do is think that you know everything just because you worked at the company for 20 years. Take a step back, keep an open mind, And obviously, we don't want to work with someone who knows nothing. So what we shoot for is somewhere in the middle. You know, keep an open mind, try to go through these use cases, take the patience it takes to do so, talk to the stakeholders, and learn what do they really need. And that's how you're going to find your domains, and that's how you're going to learn, you know, orders over here is for these types of users that manage orders this way, and orders over here is for a completely different purpose, and that could be a different microservice. And as far as the relationship between that data, don't even think about that until you get through this first part, because then we'll deal with how we deal with the data issues. So when we take this step back, what we're trying to do is break Conway's law, right? Or actually follow Conway's law in a better way with our solution, which is, you know, the way the organization wants to work with the applications is the true domain. So your software should reflect that. Otherwise, the users, the end users, are going to end up being compartmentalized in the way that your technology view looks. So we want to go the opposite direction so that we can improve, and that's the goal. Now, design doesn't stop there. Now we have to think about things like what is a service and how big is a service and what does it own in terms of the data. So let's take identity again. I know behind most identity systems with Identity Server, we have a config API and we have a runtime API for login. Login owns the users, config owns the config data, and that all makes sense. So now I have two microservices. But then we deal with things like, well, I have this UI for configuring the system, and then I have this other UI for managing the web, and then I have this other UI for self-service. But, you know, they can call those microservices, and that would be fine. Maybe it wouldn't scale for 2 million users. Maybe it would depend on scale. So now we're introducing, what are one of the things that help me decide how small my services should be? I've already identified that, you know, identity web needs runtime login, for sure we know that. But now we need to think about how far should we go in terms of granularity. So one way to go is to migrate your way towards this is to maybe build separate controllers or even separate APIs just for the different views into the data, even though the data is shared. And that's a way to start thinking in terms of interfaces. These methods belong in this service. These are different, you know, contracts, if you will, into that data. And of course, right now, I still only have 2 microservices because they're sharing the domain, which means this is the unit of deployment. They all own the same data. They all work together. And when I update one, you know, when I deploy these, they go together, basically, right? It's got the same life cycle. But what if I have 20 million users? What if runtime needs to be fully optimized? And maybe I don't want to be sharing the same data store for those things. What if the life cycle of updating user management or self-service actually needs to be done by a different division of the company and we need them to have their own autonomy? So now we're getting into, well, maybe I need full stack isolation and maybe I need each of these to be a service. And the first thing you're going to say is, well, but how do I deal with that data issue? Don't think about that yet. You have to stop yourself and say, I know I'll work that out. Let's just pretend for the moment that we know that whatever it is I do behind each of these microservices can be fully isolated, so each of them own their own data. And now we've got UIs that match nicely, and it's starting to look like a bit of a clean solution. So we're making progress. It's not achievement unlocked yet. There's more to do, but it's a start. And so now we deal with the data problem. How do I make sure that if I am locking a user or deactivating in the management or adding my new registration over here, that all of the other data stores eventually know about it? And the answer is, of course, eventual consistency. So not that you're going to do it at the data tier, but that's the thing we need to happen, right? New user created, it's got to produce a user so they can log in. Eventually it gets there. Users deactivated, it's got to eventually, and eventually it means milliseconds, right? If everything's running smoothly, then we make sure that the user can't log in anymore because the isActive flag gets turned off. So we trust that we can get here. We haven't talked about how yet, but with that story, I can keep this purity of separate microservices and go to this level of granularity, and therefore these can scale to whatever they need to scale to, which might be different, and they can be updated to whatever the life cycle of demand is by our business units without a problem. These are good things. Okay, so now, achievement unlocked, sort of. We've got this idea of these granular microservices. We think we kind of have teased out the right domains and even experiences in the UI and business users. And we still have to think closely, what is a microservice? Because a microservice is supposed to have one job, it's supposed to fit in your head, it's supposed to be small enough, but that doesn't mean it is only one service entirely. It means that it is a unit of deployment. Like a pod, in Kubernetes. It is a unit of deployment that will always be deployed together, even if not all the things changed. Probably it shares the same aggregate, of course, but that doesn't mean that it always is only one container or one service. And the reason I bring that up is just because, the whole idea of the principles of microservices are nuanced. And sometimes you run into these things and you go, but I'm breaking the principles. What am I going to do now? And you know what? You have to get over that. That's all I'm going to say. So it depends, and it's okay. So is it one microservice? Probably not, because I have config and users. That's obvious. Is it 2 microservices? I don't know, maybe, depending on if I'm going to break down the data on the back end, and also depending on whether or not they should just all be part of a unit. And it is easy to love a theory with all of these things, but Jim Counts I work with, and he said it one day, and I said, I'm going to totally steal that. So, the theories of principles and microservice, but at the end of the day, you're going to be in a room together with people, and you're going to have to make these tough decisions, and you know what? You got to move on, because you got to get something done. And you're going to want to, you can have these strong principles where you're following everything by the law, and you can also have no principles and just do whatever you feel like and be a cowboy, and probably none of those work out too well. So how about somewhere in the middle, right? Try your best to follow the microservices principles, and then, get something live, because you know what? You're never going to stop refactoring. We don't like unrefactored code. Code has to be constantly touched to keep it current, to keep it reviewed. Every time I review a piece of code or an architecture, there's always something we can do a little bit better, a little bit different. Get to a good point and move along. Okay, so we've survived. The business knows why we're doing this. We have a goal to reach. We've gone through design, and in the process learned a little bit about the whole system, hopefully, just as many parts as we can, so we can find some patterns for the growth into the future. And then we tease out of that the thing that will satisfy the business in this first 8-month period that we're going to release something. Because that thing we do in 8 months, if it doesn't satisfy something that helps the business, then you might end up throwing out everything unless the business is committed to this, unequivocally, even after spending all the money and spending all the time. They want to see business results. Make sure you focus on that. Tease the right thing out, and now we focus on how do we survive the development phase. So surviving development really just means, making sure that early on we're adopting practices that help us be productive and help us achieve the goals, right? And one of those things, of course, I'm a huge fan of is the fact that Docker makes containerization so accessible. In development, it's helpful, and of course, throughout the whole DevOps lifecycle, it's helpful, and then it plays well into the container platforms. But the number one thing I will tell you that I really highly recommend you do is the ability to take your source, all of the services you're building and working on, and essentially those repositories will have their compose files, each API, each web app, each projector, whatever those assets are. And you will be able to compose up that whole environment so that I could onboard new developers and say, hey, install Docker, git pull, compose up, and you can see the whole solution running. So that's one thing to do. The other thing is dependencies on the cloud. So even just recently, we were working with a group that, struggling to have environments that are ready in Amazon or Azure that are in a situation with the right data in them that we can just onboard somebody quickly to fix up one API or one web app that they never worked with before. And now we've got this whole setup that we have to go through just to be productive enough to make a change in a piece of code that we don't usually work on. And the way to get around that, one would be, of course, you could just make sure that all these environments, so you could spin up a new environment in the cluster with the database backend and the initialized data and have some scripts for all that. But that's hard. It's hard enough to just do automation in the cloud for your environments that you need to manage for test and UAT and prod. So reality is you could just invest some time as a developer and bypass all that nonsense and compose up all the dependencies. And even compose up initialization containers that will put some data into these, right? Single line of code, compose up, and that instruction gets you onboarded and up and ready. And now I go to Visual Studio to edit the one thing I wanted to change that can hit these local configurations and do the job. So invest in that because it's well worth it. Number one tip. And at the end of that, for the identity solution, that might mean that all of these things run in containers. I've got a Postgres container, so everything with a shadow is a container. And the Postgres container gets initialized with some script so that I can have a seeded set of users or configuration settings for the environment, and I'm good to go. So absolutely that, and then of course, we know that it works on your machine, and it will probably also work in the cloud, so when you're testing, you can do a compose up and see that your stuff's working with containers, and then, of course, when the container image is built in your CI/CD process, that will just go to your cloud deployment. Now, speaking of that, of course, we know that when we build containers, we need to, or when we write our source and we're building our container images, that we're probably going to want to build those images and test locally, but then push them up to a registry. So manually, on my command line, I can just build the image, and then I can manually push it to a registry. And I'm going to tag those images with whatever makes sense, but usually the latest one I build is, you guessed it, latest. That's great. And then I'm going to have tags for maybe product releases or check commit identifiers or something of that nature, so other labels. And you can automate that with your CI/CD. So when I commit into GitHub or VSTS, I can have a build step that will take the source, pull the latest, build the image, push the image to the container registry, and then, of course, that gets tagged. You can automate the tagging, et cetera, et cetera. So once we have that, now we have an issue of, okay, so what is the importance of tagging? Why are we even talking about this in terms of my life cycle of survival as a developer? And the answer is, I've had developers where they've committed some images to a master branch, and guess what went to production? Latest. Because somebody didn't know that you never put latest in production unless you really are committing on the right branch, and you really do have a full CI/CD process ready to go. And these guys didn't, so latest went to production, and things were not going well, and they figured out what happened. Not right away, because that was a weird problem, right? So somebody just didn't realize that latest was being pulled in production. So the rule of thumb I like to give people is, until you really are 100% for sure, CI/CD, master branch, and have better control over all your peeps, I would say, why don't we just say dev gets latest, and that's my cloud deployment for testing, and everything else has a specific tag, and that's what we pull. And if that one tip is the one that you take away from today, you're welcome. So one day that'll matter. Next thing, what about repositories? Oh my goodness, another dilemma. I'm in development, and I've got all these microservices. Should I have one solution? But that's not a microservice, right? Here's the thing. The goal is one repository, one service, Docker file, done. But that's hard to do, right? Because if you're, say, a few people working on a new project, let's just say identity server solution, and there's 25 projects that need to be loaded because it's a microservice solution with events and messaging and lots of little running around, front ends and API middle tiers and back ends. Maybe it's not so productive until we've got a baseline to separate it into those repos. Don't get overwhelmed with that stuff. You need to be productive, you need to get stuff done, but what you need to remember are the principles why we separate the repository, and that is we don't want to share code. The whole purpose of microservices is that I'm not going to accidentally build a new release for a different service and get some update to an assembly because we were sharing. Assembly updates like that need to be very carefully controlled. So I'll talk about that. But in the meantime, just speaking to this discussion, single repository per, per service would be ideal. You got a Docker file, you produce an image, and that's the lay of the land. And then ultimately, that's the container that gets run. If you can do this, if you can subscribe to this, great. It does force you to think right away about the sharing of code, because now your shared assemblies are also in a separate repo, which means it's going to be a pain, right, to go and create these solutions that load all the different repositories into one visual solution to work on. But it's worth the pain if you don't feel like you have control that later you're going to go back and do this, because you know what, you kind of don't. Go with a separate repository, maybe create a joint solution, and then eventually get out of the habit of the single solution and use Docker files locally, compose up for the stuff you're not working on right now, and only open, you know, the applications that you care about at the moment. Shared code is a thing that they usually frown upon, right? Microservices is not a proponent of shared code for the reasons I said already. You don't want to update accidentally another service. There should be clear boundaries and isolation between all of these things. But you're going to have to share code, because what about API security? I don't want to write that code 5 million different ways. In fact, on the contrary, I want that code written the same way everywhere, because I've seen it where people didn't do that, and they had these, oh, we're autonomous. Okay, fine. You're autonomous, and now you moved from one identity provider, possibly to another, and guess what? Somebody didn't write the code the same way. That identity provider did things a little bit differently. Now you have to go figure out of all the 300 apps that you have, who's playing nice and who's not playing nice. How about you just share a library and get things like this standardized? But it could be shared with a NuGet package, and then it's explicit that you opt in. And so if we update the way we do the security, and it's a required update for everybody, you need a procedure for that. Standard operating procedures. What do we do when there is a critical fix? And all of those containers should get rebuilt, pull the latest NuGet, and that's what you're testing with. Otherwise, if it's more of a feature thing and you can opt in when you're ready, then you're not impacting all those other containers. Standard operating procedure. I have an optional, update to this package. When I'm ready to use it, I will. Thank you very much. You didn't affect my container. So prepare to refactor again and again and again. You're not going to get all of this right the first time. You have to go live with something. So now we can talk about troubleshooting. We've survived design and then development. Hopefully some tips to help you be successful with that process with some of the common dilemmas that I see. And now we have to talk about instrumentation, because guess what? If you don't write logs, you don't have them. Thank you, Captain Obvious. So you have to start this from the beginning. And I don't mean write logs, oh, I installed Serilog, everything's good. I mean intentional logs. I mean taking care for consistent ways for all the apps to enable logs, and thinking through what is our policy or strategy around logs, and telling developers, don't do method entry logs, for goodness sakes. It's not useful. So we look for logs so that we can do things like end-to-end tracing. This is the dream, right? What I want to be able to do is I want to have an activity that happens where the user says, hey, I'm going to log in. And the first thing that the system does, maybe first launch, is goes to the config and loads and caches the config, gathers some things, and then it goes over here and logs the user in, gets their profile, checks if they're active, a couple of calls happen. And then at the end of all of that, we're going to be logged in, and then eventual consistency, maybe some of those messages around the login or a lockout activity get played over to audit, endpoints or things like that. So that whole thing, the red dots ought to be connected by something, because what I'm looking for is visibility. What I'm looking for is thinking through right up front that when I add logs to my solution, that when something happens and goes wrong at a certain point, that I actually can just click that link, check the activity ID, and see all the things that led up to exactly that. And I don't care at that point in time, method entered, HTTP called. No, I care about actual concrete things that happen at each of those points that were meaningful. Information logs, not debug, not maybe some debug logs, but mostly it's all about meaningful logs at each point in time. So interesting things happen when you start to do that. Now I can see from start of activity all the way to end of activity, all the things that led up to the error. Maybe it's not even an error. Maybe it's a message that happened and I want to inspect something. Again, go to my logs, check the activity, get the whole picture. And when you start, actually using your logs this way, then you actually discover interesting things about the meaningfulness of your logs, or lack thereof. For example, what about this? Informative logs, maybe. So some logs are actually useful. They mean something happened. It could be an exception. It could be something, of an activity, like user logged in with SAML. But this is not informative. However, it did teach me something, that my error page had an error. So I had an object, some sort of null passed in, and that actually meant that my error page didn't have the information it needed. And I saw that because guess what? I'm troubleshooting with my logs. Because I don't use Docker debug in Visual Studio, I actually go and try to troubleshoot my own stuff with my own logs, because then as a developer, I'm actually helping to reach the goal of meaningful logs. Because I'm going to know better than anybody, right? I'm the one troubleshooting, debugging, going through that day to day. So as soon as I have enough of a code base to make that worthwhile, that's what I should be doing. And then I've got weird logs like, again, method entered, completely useless. Okay. Debug with your logs, and it will be something you'll be very grateful for later. You will also start finding interesting things like, oh, wow, well, of course, method entered. Let's get rid of those. Yeah, I should clean those up. I delete those things now when I see them. When I'm working on code bases and doing code reviews, security reviews, I'll just like, that's gone, out of here. Next thing is, why am I seeing 3 logs of the same thing? Take a look at it, right? Clean it up. How about passwords in the logs? That's never happened. So, HIPAA, GDPR, lots of reasons to care. All right. Now let's think about microservices' views of logs. So everything being a microservice, of course, my logs should include things like which component I was in, which microservice I'm in, whatever's meaningful around that, maybe what environment I'm in, prod, et cetera, et cetera. Is it Michelle's machine or is it Joe's machine? And guess what? Now you can go to Kibana or your other logging infrastructure, and you can start building views of the microservice itself, and then build aggregate views that show sort of the overall status of a group of microservices, maybe the identity microservices. And then you go up another level and you have dashboards that show, the whole system or a whole area, like a department's worth of products. So you build these dashboards, and they can have these different layers of views, because now you have these interesting logs, and they do go end to end, and they give you good data points. So these things should be happening early. It's a parallel thread. You do your job as a developer to collect the logs and make them useful. And then early on, when you're deploying to your environments and your orchestration cluster, somebody can start thinking about views of data and troubleshooting information and so on. Because the other thing we like to do is have developers all push their logs from their various machines as they're debugging and troubleshooting up to a common area, Elastic, for example. And then that way, the person who might be doing the ops side can actually see those logs and do something with it, and build these filters of views based on real data that's actually kind of happening while we're building the product. So it's really useful. Next, surviving eventual consistency. So I bring this up because a lot of the solutions that I do not throw messages lightly at a system. Just because I'm a fan of the architecture doesn't mean it fits everywhere. But I do say this. If it's a fit for your architecture, because you want messages to get better visibility into a solution, like what's happening in workflows across the various products, then when you take that into consideration, the end result of that is a lot of powerful things that you can do with those messages, like what I'm going to talk about. So eventual consistency means that, when something changes in, say, the right store, the right side, I change the configuration, it eventually pops over to the runtime. Same thing goes with user and identity. And as, you probably would expect, there could be a few of these paths that can't be eventually consistent, so those you're going to have to find a way to go direct to the read store. Worth mentioning. Now, each of these being a microservice, owning their own data, eventual consistency on the back, Using a message-based solution, I can pop in messages out of each of those services, and then with those topics, each of them can be a microservices topic of their own. And then those messages get replayed into, from a projector, the data store at the target, okay? Now, with that in mind, what we're looking for here is now a vertical that represents the microservice, which is the API, the collection of messages. A message is never repeated in any other, so it's not hard to follow, right? You're keeping everything that fits in your head in the vertical. The microservice fits in my head. I have maybe 20, 30 messages max. I've got an API surface area. I have a projector that knows how to play those messages. And I have a data store that gets the rights from that. And with that, now I can do really interesting things like, what if I want history and audit tables? So now, without writing code that creates a history table or an audit table, in my mainstream code where the activity happened, I can eventually project that. Because I can take these messages as a source, and I can say, hey, let's spin up some new projectors, pull those messages from the beginning of time and now into the future, and let's project our history table for all the things this user did, and who gave them this permission and that permission, and who took it away, and also all the audit. They logged in, they logged out, et cetera. So we start to get messages that will represent the flow of things that happen with the user. And it gives us that kind of sort of for free after investing in the messaging architecture. So messaging also should fit with your end-to-end visibility story, which means that the ID of an activity, like I started a login, should also include that activity ID through to the projectors, because then we can also do things like tie in things that happen eventually with the original request. So now I know this audit table write happened as part of that user's login on that day. And you can tie that all together with your not only with your messages that you are saving, but also with your logs if applicable. So this gets really interesting, right? Now, when we talk about messages being now basically so prominent in the ecosystem of this solution, for example, that kind of means the messages are the source of truth, but they're eventually projecting to the read store. So the most current state of what's happened is actually the message, right? So I'm active or I'm not, I got locked out or not, that kind of thing. Now, of course, it's not that easy to write messages to, say, an Event Hub or a Kinesis or a Kafka and be able to quickly query, hey, is this user locked out or not, right? So there are tools out there like platforms like Event Store, where actually the messages it's not just a messaging architecture, it's also a store. So it actually represents the user. Everybody would have their own user stream, for example, in this architecture. And that user, you can always ask the aggregate, are you logged in or out? Because essentially all the messages play back extremely fast for that stream. So at the moment of login, I'm actually not checking the read store to see if you can log in. I'm checking the actual stream. And it's a special platform that supports exactly that. And I've seen that done with other messaging architectures, colleagues of mine who have implemented that, but that's just harder to do. And this is built from the beginning to do that. So I'd say if you're looking for what's called an event sourcing architecture, this is your go-to. It's another way to solve the same problem, and what that means is the messages are actually building a stream, and the projectors are still reading the stream, all the same. And the difference is that now we have a central way to manage, a central way to ask the current state. Now this starts to look like one microservice, right? Again, it could be, in the sense that they're sharing an aggregate in the middle. So this is where we get back into the, again, this will scale wildly because everybody has their own user stream, so there's no contention, right? Multiple threads, et cetera. But it starts to look like this is one aggregate, and now we get into that original problem I said, which is we have design decisions to make. Move along, make the decision. You'll refactor later if it sucks. So surviving integration. This is really interesting because microservices implies I mean, obviously, you're going to have a lot of little services running around, and we're going to need to have unit tests for each of those. Every microservice fitting in your head suddenly makes it really easy to write a reasonable number of unit tests for every single one of these services, right? So maybe we can have some better practices as a development team, and also to automate running those tests in a container to hit the service as you commit, and have your build process of the image take it through that process automatically, right? Associate your unit tests with that. And it's all, again, fits in your head, every microservice, manageable amount. But there is another really interesting thing that microservices asks us to do in terms of principles, and that is we speak about consumers of your service providing the test cases. And this is really important because I don't know if anybody has ever written test cases or written unit tests for a service and then found that somebody uncovered a way that that service could be used that you weren't expecting. So I can write my unit tests for how I expect you to write the method, but maybe I don't realize that when we create users over here, that there's this back-end process that's going to bypass the password protection and maybe produce a different record for a user with grandfathered passwords that don't match our policy, the new policy. Or the workflow they're going to go in, they're going to enable, automatically confirm the email even though they didn't go through the email process, and I didn't realize that that could be a use case. So how do we discover those things? Well, anybody using my microservice, right, should be able to say, we're going to call it from this app in this way, and we're going to call it from this app in this way, and I should be able to collect all that as information to the requirements for my testing. So my unit testing, that's all fine and well, but what I want is integration testing that won't blow up, right? So I'm looking for a solution, which means you got to help me know how are you going to use my service so that we don't end up with something like this, which would be really bad, yeah? Now, surviving launch. So I've instrumented everything beautifully. We've got logs. I've debugged with them. They're awesome. And I've got unit tests and integration tests, and everybody's done their job. And this is all a lot of work, right? Design all the way through to development, new tooling, et cetera. Deploying automatically latest to a development environment, maybe a test environment so we can test and get used to running the platform, right? And now we're going to go live. So how do we prepare for that go live, right? Your solution's in the middle, and these are all your users. They're going to hit the next day because you're a startup who knows you're going to be wildly popular like Pinterest in just a day and have 20 million users that will crash you down. Or not. Or you already have 20 million users, and you know that you have to prepare for that right away. So all these things are possible. And ultimately what we're saying is, when you hit the button to go live, go to production, just imagine there's somebody out there saying, prepare to fail, right? Because you got to be ready to roll back. You got to be ready to roll forward. You got to have standard operating procedures for solving problems. And the only way that you know you need to do those things is by actually making an effort to make it fail already. So when you decide to go live, you've got your automation for the infrastructure and all of that. You've got your automation for the deployment of the containers and all of that. But we need to try to break the solution. And so the idea here is you create drills, try to tip containers, try to load them up. And it's not just load testing, it's other stuff. Kill containers in the solution and see if they come back. Take a node out and see if the containers redistribute. Turn off Redis, turn off one of your data stores. What happens? Does everything blow up or not? You got to try these things. Put a message that's bad in the event hub. You got to have these drills, try them out, and then you've got to document the standard operating procedures around how to solve problems. Like maybe one of your drills surfaces that after a period of time running in the environment, one of your nodes gets too many images and disk is full and nothing's deploying. So a standard operating procedure would be, how do we get into the box and look at the nodes? What's the procedure for that? You need those things documented and ready so that somebody who's trying to solve a problem can go do it. Or where do I go to find these events or these messages? Or where's my dashboard for this and this and this? Those are the things you're building and refining and perfecting during this process of just pre-go live, to see how far you can take it and break it So it's basically, you know, it's a process that takes effort. And somebody's going to put latest in production. So I'm just going to mention that one again and say don't do it. It's a full-time job looking for things to fail or ways to fail. And you need to put that time in to try to fail so that you can learn what are the things I should know about managing that situation. And once you've accepted that you can have those flaws, they can't be used against you. It's the beautiful thing. So with that, we talked about at the beginning that it has to be good. And so we need to survive all of these things that I've called out in order to make sure that we're doing all of the procedures and following some level of guidance to be successful, yes? And also accept that it can't be perfect. It has to be good, yes. But let's call it great. Fast, not going to be fast. Cheap, not going to be cheap. Why? Because you have to invest in that first 8 months, because that first launch has to satisfy the business and the thing that they wanted to solve, the problem they wanted to solve. It has to be impactful so that they say, this was totally worth it. And you need to spend the time that it takes to get there, which means people, resources, money, possibly trainings, new tools, expertise, consulting, all of it. But you invest in that up front, and now you're ready, really, for the growth, right? The first launch is going to have a couple of services solving that one main problem. Exponentially from there, you'll start to increase the number of services that you are able to release and deploy and manage because you did so many good things and right things up front. And I will throw out there, just as a swag, that a POC is probably, you know, like a quick POC that just does that basic architecture without it being the full implementation. You could spend, you know, 6 to 12 weeks. And you could spend some money on that with resources, right? And just get something done quick so that you can see, okay, this is the platform, this is the messaging architecture, here's how messages work, et cetera, as an example. And then you're going to spend probably up to 8 months to go live. And you're going to spend lots of resources on that because of products and tooling and training and all of the things. People, bodies, they cost money because you'll need more people probably, right? New people or consulting. One of those things is going to happen. And then you get to start taking measurable benefits from that investment. And I'm just throwing numbers up here. I want you to know that these are examples from just looking at a smattering of different situations across people I work with and teams that I've seen go through this process, even internally as businesses, right? With their own resources. So just keep those things in mind. Remember that it's costly to do it, so make sure you choose the right reasons to do it so the business can say, this was worth it. And with that, I would just say the answer to the question, can you survive microservices, would basically be if some of these pieces of advice are things that you follow, I think you can, and then you will be prepared for winter. Thank you. He's scary.